Remix to Cognition.
So I have bad news. And that bad news is that your brain sucks at braining. I have good news, and that good news is that your brain is not the only brain that sucks at braining. We are faced with a deluge of data, bits of ones and zeros coming in through photons and bits of waveforms coming in through sound waves. And it's our brain's job to distill some of that information into something that we can understand. It's not great at its job, but it certainly could be worse. If you think about the immense processing required to turn a bouncy photon off of a red sweater into a percept of a human wearing a red sweater, it's very easy to become awestruck by the complexity of the system that's contained within our skulls. To scale back, though, when you realize that everybody thinks that they're an above-average driver, and most people think that they're above-average intelligence, something doesn't seem to compute. Why are we so bad at assessing ourselves, at assessing other people, but so good at filtering out information from the environment to make decisions, most of the time? Two sides of the same coin, my friends. In order to make information meaningful, we need to filter things out. That's the critical bit. We need to filter things out. We can't take everything in. We only have our own experience to work off of. We are our own normal, and so we are going to use our own experiences to compare the rest of the world around us. Now, one instance of this is exhibited in the Dunning-Kruger effect. This is an effect where, essentially, people who think they're pretty good at things are typically not. But on the flip side, people who think that they're poor at things sometimes excel. This is a tragic case of misperception of self and capacity. Now, this is a relatively high level thing. Like I mentioned, most people think that they're above average drivers, which collectively, that's not possible, right? The average is the middle of a bunch of numbers. We can't have a bunch of people on one side of the middle of a bunch of numbers, otherwise that middle won't be the middle anymore. How can we all think that we're above average drivers? A very natural question in following hearing about the Dunning-Kruger effect is, how do people not know that they are as bad as they are? Or how are people maintaining this idea of themselves without reflecting on what reality is giving them back for information? So there's a lot of ideas as to why here, and I will give you my suggestion as to why this might be. And I think that one of them is that we cannot correct course of action for which we have not received feedback. So in my own research, I look at attention and learning, and I know that people will learn over time to pay attention to more informative parts of the environment. I expect that people who overestimate their abilities are not looking for features that provide feedback to them in order to compensate for their shortcomings. So, popular reality shows where you audition to sing, if you haven't been seeking feedback and you are very confident that your capacity is above average, then you're not going to be hearing feedback. Remember, we have that deluge of information in our system, and we have the challenge of filtering out the bad stuff. It's hard to get the good stuff because, as we know from other fields, the signal and the noise are sometimes hard to tell apart. So, if you have decided ahead of time that your capacity is established and you need no feedback to confirm or deny your capacity to drive well, to do math effectively, to cook well, whatever it might be, if you're no longer seeking feedback because you are working on other parts of your life, it's very unlikely that you will integrate information from your environment in support of making changes to wherever your delusion may live. So This is back to very classic philosophy. We've seen many philosophers say something along the lines of, the smart man knows what he does not, or that kind of thing, to say wisdom really is knowing where your fallibility is and how far your capacity is limited. Okay, so this is pretty high level stuff. So this is sounding a little bit more like a self-help podcast than a cognitive science podcast, and I understand that. Let's dive down a little bit deeper and think about something that has fewer moving pieces. So, if you are reading an old text, sometimes your pages will be scribbled on, or you'll have maybe a missing page or a cut or a rip, but usually that old book is still readable. Why? Because you are able to fill in the gaps. At low levels, we can fill in the gaps using just really basic visual processing. So for example, if you have two lights moving in sequence close by each other, we get the sensation that they are moving when in fact those two lights are simply blinking on and off in succession. It feels like movement because that is how our visual system has evolved to perceive the world. So we have this induced motion from blinking lights. In your textbook, you have the induced vision of a full word where an O might be scratched out or an I may not be dotted. This is in part by your visual capacity to fill in patterns, but probably in larger part to the top-down influence of knowing that the word dog is more common than the word dag. This top-down, bottom-up tension has existed for a couple of decades of very prolific research. The tension between, do I do what I do next because I know that that's the right thing to do, versus do I do what I do next because information from the environment has elicited this behavior from me. Like most binary questions, it's probably somewhere in between the two extremes. There's probably an influence of the environment in making you act in a certain manner, and there's probably an influence of your previous experience and your ideas about the world in priming you to act a certain way. The intersection between these things is pretty complicated, and one of the failures of the cognitive system is that sometimes that top-down, the expectations of what to do next, can supersede valuable bottom-up information. So one example of this, it's a pretty famous one, where two teams of people are playing basketball together. One team is wearing black t-shirts, one team is wearing white t-shirts, and you as a participant are asked to count how many times do people pass the ball to each other. Actually, to make the task easier for you, I'm going to ask you to focus just on the people in the white shirt, passing the ball back and forth to each other. You count the passes for approximately maybe a couple minutes, and then at the end of the experiment, I come and ask you, thank you for counting those passes. Can you please report how many you saw? Can you write that number down or tell me? And then I would ask another question, and that question would be, hey, by the way, did you notice a gorilla pass through the game and bang his chest? The question seems out of nowhere. You were counting passes, you were diligently doing your job, and I dare ask you, if you saw a gorilla pass through the game, what kind of absurdity is that? Well, Simons and Chabris saw exactly the blindness that this story suggests. People were often, maybe about half the time, people were blind to a gorilla passing through the game. Why can this be? It seems to be the case that the desire to accomplish the task, that goal-directed attention, supersedes the ability to see things that are unexpected in the environment. Naturally, a gorilla passing through a basketball game is particularly unexpected, unless maybe we get the Vancouver Gorillas coming out in place of the Grizzlies. All this is to say is that attention is powerful and desperately fallible. These are a couple of examples of how your brain sucks at braining, and I assure you there are more that we will go into as the podcast proceeds. What I'd like to do next time is to talk about ways to challenge these problems and to minimize the probability that you fall into traps that our system is so set up to allow you to fall into. Until next time, take care.